Hello, I'm David Boyer, Danfoss Service Training Coordinator. I'm going to show you how to use the MCT10 scope functions.
Please take a moment now to pause the video to read the safety warnings shown here. Failure to follow these warnings could result in death or serious injury.
What I have going on here on the left side of my screen is my virtual keypad plugged into a live drive. It's plugged into this drive. Now scoping, where it all begins. I'll right-click on Project and expand the New menu and choose New Scope folder. Once I expand Project and highlight that, here it is. Notice these two choices are grayed out. What it's looking for is what drive do I want to scope? It's this one. Once I select this, it by default chooses PC polling channel. The other choice, drive real time channel, that involves configuring a drive to store data within itself. You then unplug your MCT10, walk away, come back at a later time, plug in and retrieve that. That'd be covered in a different module. We're looking at the PC polling. First choice here is, what are we interested in seeing on our scope? Long list of choices. All of the data readout parameters can be scoped. Let's just choose output frequency. Clicking next brings up a dialog box. I'm going to hit OK and just accept the default values. And I'm going to go up here and choose Start Data Acquisition. Let's run down the line here of all of the icons. Start Data Acquisition, stop, resume tracking, pause tracking, scroll axes, zoom axes, auto scaling, zoom out all axes, zoom in all axes, select, zoom box, cursor, clear buffer for a particular channel, reset scope, meaning clear all buffers for all channels, export a scope to Excel, scope storage. I'm going to click that right now. I'll show you why later. And then open scope history. Those are the topics we'll cover. Let's also look here. If I right click in the scope window and choose properties, this reset scope has the same function as hitting reset scope here. Properties brings up a dialog box with 4 tabs that we'll look at individually: general, trigger, data storage, and cursor. Now let's just cancel that. I'm going to highlight the one channel that I have on my scope, right click and choose properties again. I've saved a snip of that previous window with general, trigger, data storage, and cursor. You see those repeated here: general, trigger, data storage, and cursor, but there's a 5th tab, polling. This 5th tab applies to that channel specifically. These other 4 apply to the whole scope globally, whether you access them by pulling up this menu by clicking on a particular channel, or whether you access it this way, same thing. They apply globally to the whole scope. I'm just going to now begin my scope. These I'll explain in time. I'm just going to hit this now to start data acquisition. You can see some activity here. It's collecting data. I'm going to hit the auto on button on my drive so that the drive starts ramping up. You can see here it's ramping up to 60 hertz. We don't see much over here on the scope. Why is that? It's because the default scaling for that channel is 1000 hertz per division, which is enormous. I'm going to show now the auto scaling. If I click this, it automatically scales that channel for me so that I can see what's going on. Now, this icon is a toggle, meaning that once I toggle it on, it remains on until I click that again to toggle it off. You can see it kind of highlighted there in blue. So it's still active, meaning that if I hit off now, Notice it rescaled that channel to 20 hertz per division, which makes sense. If I hit off, it ramps down to 0. It's at 20. Now it's going to rescale that again because that auto scaling is still active, and it's going to go to something crazy low, 1/10,000th of a hertz per division. So what I would recommend is once it auto scales, once things are ramped up to where at values you expect to be working with, toggle that off. Now I hit the off button, it maintains that 20 hertz per division scaling. Let's hit the stop data acquisition. Let's add some more channels to our scope. Here's how you do that. Down here in the channel window, I'm just going to expand that a little bit so we can see channel numbers. Right click, add channel. Let's also look at motor voltage. Click next. Again, I'm going to choose defaults. Let's add another channel, motor current. Click next and OK. Let's add DC link voltage. There won't be much activity there, but now with the full licensed version of MCT 10, you're able to add 8 channels on your scope. If you're working with the free version, you're limited to only 2. I'll show one other thing here. Let's add another channel and choose digital input data readout. And I'll show you how that looks on a scope. Just choose defaults there. Let's start data acquisition again. Let's go and hit the auto on. Now, my frequency channel has reasonable scaling so that we can see it, but these, again, are all crazy high. Let's choose, again, the auto scaling. Let's toggle that off. We can start and stop. Okay, what happened here? Let's pause the tracking and examine what happened. When my cursor is looking like, or my pointer, looking like a finger there pointing, I'm able to drag the scope around. Now, my motor current shot very high while stopping, probably because the motor model isn't great. There's a big mismatch between my drive size and motor size. So these are all auto-scaled, and these values are saved. I'm going to highlight motor current, choose properties, polling. Remember, that's the only tab that applies to this channel specifically. Let's change the scaling so that we can see what happened there. And there it reduced it so that we can see how high that current spiked. You can scroll back in time here as long as you like. Okay, I'm going to show you here now. I've got the digital input 1660 channel. It shows this binary string. Let's resume tracking. I do have control wiring on my drive. I'm going to turn all the digital inputs off. And what you see here is a 1 for the safe stop input, and then followed by 6 zeros, each one representing a different digital input. And I'm going to go down the line here and turn on input 33. You see that becomes a 1. And then 32, 29, 27, 19, and 18. I'm going to pause the tracking, go back here, and if I bring up a cursor, we'll look at the cursors more in depth in a moment, but I'm just choosing the X value cursor. And notice as I go back in time here, all of my digital inputs are on at that moment in time. If I scroll back here, you can see now 18 is off. Scroll back here. Now you can see 19 is off. Scroll back here. Now you can see that 29 is off. In other words, if I scroll the whole graph, I can see them, whatever state they were in at that cursor position, it's reflected down here. That allows you to capture at any point in time in your scope what were the digital inputs, or what were they doing. You could also do that with the relays. Let's talk about these first 4 icons here. Stop and start data acquisition, resume and pause tracking. Start the drive, ramp up and down. If I pause the tracking, I'm still acquiring data. Notice these values change here, reflecting the speed that the drive's going. It's still acquiring this data. It's just not showing it. If I resume tracking, it'll catch up to where it was. Let's pause that and look back. And you can see all of that activity was captured. Let's resume. Now, if I stop acquiring data, on the other hand, while I'm ramping my drive up and down, there's nothing happening here. It's not picking up any data from the drive. If I ramp down and then begin acquiring data again, what it did was it just drew a straight line from where those values were when I stopped acquiring data. It had to advance in time. But then when I start acquiring data, it draws a straight line from where it was to where it became here. Notice also if I resume tracking, ramping up and down, if I just click here in the scope window, it has the same effect as clicking the pause tracking function. And then I can resume. These 2 icons, they're a pair. Scroll axes and zoom axes, always one or the other is active. Right now you can see in light blue there, the scroll axis is active. What that does is I can drag the scope. I can just scroll around and look at find a particular point of interest. Whereas if I choose zoom axes, I can change the scaling. If I click and drag downward, it proportionally changes the vertical scaling for all channels. Let's resume tracking and get a little more action there. Still zoom axis is active. I can compact the vertical magnitude or expand. Same with scrolling left and right. I can change the time units per division. Contracting it by scrolling that way and then scroll this way to expand it. That's what these 2 do. So scroll axes, zoom axes. We looked at the auto scaling. Zoom out, clicking that, it contracts both the X and Y axes. Zoom in, it expands them both. The other way to get a look at a point of interest is this zoom box. When I activate that, again, that's a toggle. It's active now. You can see it in blue. And you can pick a particular part that you want to scrutinize and zoom in on it. Let's deactivate that and zoom out. Scroll left and right in time. Reposition the cursors. We can access cursors here. In the scope properties under cursor, here's where you configure the cursor. By default, it is Y value. So let's hit OK there. bring up our cursor, and wherever we put that cursor, it'll show the readouts of the different channels in whatever position you're on. Let's see how high the current spiked when we stopped. We can come over here, and we can see it shot up to 1.9 amps per division. It dipped a little bit to 1.84 amps per division. That's how the cursor works when you choose y-axes. There's other choices there. X value, hit OK, put the cursor up there, and it'll show you the position in time. In other words, it's just going to reflect the time scale that we've got going on there. Other choices for cursors, delta X. So it's going to bring up two cursors. When I activate that, it'll show you the difference in the X value. In other words, the difference in time. So it was 662 milliseconds from that first current spike to where it ended. The other choice for cursors would be delta Y. That's going to give me two cursors on the vertical axes, one here and one here. And I can see that motor current jumped 2.03 amps from here to here. Turn the cursors off. Resume tracking. This next icon, clear all buffer for the channel. Let's pause our tracking. Come back here so where we can see something. If I select over here a channel, let's select motor current, I can clear that buffer individually. You see the current trace disappeared. There's no information there. We could clear the DC link voltage buffer. We'll see this purple line disappear. The buffer's now empty. On the other hand, this will clear all buffers. Reset the scope. There's nothing there anymore. Resume tracking. Auto scale again. Turn it off. Let's stop tracking again so we could rescale our current channel. Current, right click, properties, polling, and we'll go back to 0.3 amps per division. Now we can see it again. Let's look at this export to Excel. You can take all the data points that are on this scope file and put it anywhere you want in an Excel format. We'll call this Excel example. We'll just go with the default location and save that. What I would recommend doing is if you could copy this path, I'll show you another feature here. Right-clicking on our new scope folder, you can say new text note, and it'll bring up underneath it a note and a screen where I'm going to paste that path. You could also, any information that might be useful here, job site, particular conditions, whatever. You can put any notes you want in here, any text. Now let's go back to our scope. Let's reset the scope entirely. We'll start data acquisition. We start tracking. You're doing some commissioning or troubleshooting, and you're scoping out information. Let's say you capture something that you like. I would give that a pause. And let's say you want to continue scoping with all of these same settings. I would do this. Right-click, copy that scope folder, Go back up to project, right click, and paste. Now you've got a new copy of the folder. Let's rename this. Let's say first run. Now maybe you want to save your parameter settings that are associated with that scope. I would drag those parameter settings down into the project, allow it to do its thing. Copy done, close this window, and then why not rename first run parameters. That way we have a first run scope trace, the associated parameters, and then we can go back here and acquire data, resume tracking, try a different trial. Let's say you're doing a commissioning and you're making some parameter adjustments. Let's just go in here. We'll stop acquiring data. Go into our drive. Let's just alter the ramp times, for example. Instead of 3 seconds, we'll make them 2. Go back to our next active scope. Let's just reset it. Acquire data. Resume tracking. Ramp up and down. See how those new ramp times handle. We'll stop acquiring data. Also pauses tracking at the same time. Let's rename that second run. Copy our parameters again. Copy done. We'll close this. And we can then go here. Get rid of those notes. Rename second run parameters. There you go. And so on. So you want to continue scoping. We'll copy that scope folder, paste in a copy, and continue on with all of the same parameter settings. Reset the scope and continue collecting data. Let's start looking at the different scope properties. I'm going to start with a new scope folder. And here it is. It wants to know what drive. The one on the USB port. Let's look at output frequency. We'll choose the default values. Start acquiring data, ramp up to 60 Hertz. I'll use the auto scaling again. Toggle that off to maintain my settings. Let's just stop data acquisition. Empty the buffer. Let's look at properties. General. I'm going to put this at 2 seconds per division. The time and date format, by default, you get hours. The N is for minutes, S for seconds, Z for milliseconds. I did program a time and date in this drive. Let's choose that and see how that looks. Now notice my x-axis is scaled with the actual time and date. April 27, 2020, 4:35 p.m. But that's not going to work for this example, so let's just choose seconds. Buffer size by default is 1 million samples. The polling rate by default is take a sample every 100 milliseconds, or in other words, 10 samples per second. I'm going to make the buffer size small, just 100 samples. This is per channel. 100 samples per my channel of frequency. If I had 8 channels on this scope, it'd be 100 samples per channel. And trigger position at 0, we'll look at that more in a bit. So if I hit OK and begin acquiring data, let's just ramp up and down a bit. It's filling the buffer, and in about 10 seconds, it stops because the buffer is full. Let's use our zoom axes to get that whole thing in the picture. Let's set up our cursors for delta X. Hit OK. Show our cursor. I'm going to put one at the beginning, one at the end, and that's about 10 seconds. It filled the buffer. Let's get rid of the cursors. Let's go back to scroll axes and stop data acquisition, reset the scope. Now I'm going to set up a trigger. Back to properties. Trigger. We're going to trigger on frequency. We're going to trigger when it gets to 30 hertz. Let's turn our drive down below 30. By default, it's in auto mode, meaning that it doesn't need a trigger. It's always active. Normal mode means when the trigger level is hit, either when it rises above 30 or when it falls below 30, whichever one works for you. Let's do rise. Then it's going to begin scoping. So now if I start data acquisition and resume tracking, it's over here waiting for the trigger. We can see that go, oh, I went up too high and it triggered. I hit 30 hertz there. So it starts filling the buffer. And again, that'll run for 10 seconds. Buffer's full. It stops. Stop data acquisition. Clear the buffer. Look at the general properties again. Trigger position. 0 means that 0% of the buffer is captured before the trigger. Let's make that 40%. So once it hits the trigger, it's going to say 4 seconds worth of information before the trigger and 6 seconds after. If we start data acquisition, resume tracking, it's going to wind out here about 4 seconds. The buffer before the trigger is full. Still tracking, still acquiring data. The moment I hit 30 hertz, it triggers. It keeps whatever was happening the 4 seconds before the trigger. It collects 6 seconds after. Now, let's say you wanted to trigger on the drive being in an alarm state. What happens after the trigger isn't going to be very exciting. Everything's going to drop to 0. So you might want to make that trigger position 90% before the alarm. The only way I've found to make a drive trigger an alarm is to set up terminal 29 as an output. And program it for alarm. And then I'll need to add that to my scope. Let's add digital outputs, add a channel, choose digital output right here. Okay. Accept the defaults. Stop. If we start acquiring data, digital output is 0. I'm going to flip off my terminal 29, put the drive into external interlock alarm. I see that climbs to 4. So I'm going to set my trigger now for digital output with the level being, say, 2. Stop data acquisition, reset the scope. Clear the alarm. Start acquiring data. The 90% of the buffer before the alarm is filling up. Let's run the drive. Ramping up and down. So once the old information expires, it starts collecting new. And all of a sudden, the drive goes into alarm. It saves what was before the alarm and gives me a second after. So that's the trigger. Let's look here now at this icon called scope storage. This is another toggle, meaning that you hit it once, you turn that feature on, hit it again, you turn it off. I would recommend getting at that a different way in properties, data storage. The advantage of doing it this way is you know whether you're turning that on or turning it off. Let's leave it off. I'm going to hit the toggle, go back and look again, and it's on. So this way you know whether it's on or off. What this does is, in addition to saving your data points in the MCT10 file, it also sends them here continually. Again, I would recommend copying that path. Let's hit OK. Making a new text note and pasting in that path. Now, you don't have a choice as to where it goes. You can't change this here. You can, however, once something's saved there, you can open that window up and we could go back to the whole folder, new folder 6, copy the entire thing and then paste it anywhere you want. Send it in an email or save it to a thumb drive. Again, I would certainly, if I did save that somewhere other than the default location, I'd want to make a note of where I put that. So here's how it works. We've got it enabled. Let me just verify for sure once again. Yes, it is enabled. We start data acquisition. Let's go back and reset our drive. Start and stop. Clear our buffer. Run the drive. So we'll fill up the buffer here once. It's waiting for the trigger. It's triggering on alarm. So put it in alarm. There, it triggered. Let's reset the scope. We'll stop data acquisition. Let's change that. Let's change that trigger back to our output frequency. Resume tracking. There's the straight lines from where these values were to where they went. And we've got to, in order to trigger, we need to rise above our trigger value, which is still set at 4. So here we're taking a number of scopes. We are starting and stopping. We're clearing the buffer, triggering and not triggering. Let's stop data acquisition. Now this icon, Open Scope History Viewer, and what we got saved here is everything that's been going on since we've had our data storage going on. So the scope here itself, we can reset the trigger, clear the buffer. We're doing all of this here. So stop data acquisition, clear it again. So the scope itself doesn't have anything at all saved. But back here again, everything that we've been doing has been saved to the hard drive. You could think of this as sort of a backup. Anytime you're using the MCT 10, if you've got this running, your whole session is saved to the hard drive, and it's essentially an unlimited buffer. Again, it has a feature where you can zoom, scroll back out again. This allows you to move the trace. So that is how the data storage works. Let's look at one last tab here. I'm going to start with a fresh scope folder. It is there, new folder number 10. Choose my drive. I'm going to choose DC link voltage. Next. And I'm going to choose 10 volts per division to really get some good scrutiny on the DC link voltage. If I start acquiring data, I'm not going to see much because the DC link voltage is at 345 and I'm at 10 volts per division. So where in the world is that? It's way up here somewhere. Let's hunt for it, see if we can find it. There we are. So if I pull this down and change the vertical position to about, let's say, 350, then I can see this real clearly. I'm just going to quickly remove that channel, add it right back in again. On this drive, pick DC link volts. For now, I'll save the default settings. I'm going to add output frequency, add a channel, output frequency. Again, I'll accept the defaults. Let's resume tracking, start and stop data acquisition. Do the auto scaling. We'll ramp up to full speed here. Auto scaling is doing its thing. I'm going to stop acquiring data and go back in and get DC link voltage the way I wanted. Polling, units per division, I want 10. The position, I'm going to have to put it minus 350 or I'll never see it. Hit OK. Resume tracking. Now I can see it, and let's ramp up and down. Now because my scaling is so fine, I can really see that DC link voltage changing as we ramp up and ramp down. Let's go back and look at other features on that tab, polling. I've chosen DC link volts again. This is just where, let's stop tracking or stop acquiring data, right? Look at this. Well, let's choose frequency. We'll look at this again. Properties, polling. This is what channel we're dealing with. You can't change anything or rename that. You can reconfigure, meaning instead of frequency, you could choose motor current, whatever. Cancel that. You can change the name of the channel. I'm going to copy this name and just change this then to, say, Hertz. Hit OK. Down here in my menu, it's calling it Hertz. Back to polling. Put that back like it was. So we've seen units per division, trigger position. You can pick a color, pick any color you want. Different channels can share the same color. Marker, I'm going to turn the marker off for frequency. Hit OK, resume tracking. what that does is here, let's stop it. You've got every polling point right here. It's showing a circle for the DC link volts trace, but showing nothing for the frequency trace. It's given a smooth line. If that's what you prefer, that's how you'd get it. We'll turn the marker back on. The advantage of having the marker on is if you're looking at a black and white print of a graph or something, you can distinguish what channel is what. Interpolation, what does that mean? The other choice is digital signal. And what that does is gives you the stair step. So resume tracking, and that's how your trace would look if you're choosing to show it as a digital signal. Put that back in interpolation. That's it for this tab, and that's pretty much it. One last thing I can show you is we've got the print folder here. If I either choose that, it brings up this menu, or same idea, highlight the folder and right click and choose print selected folder. It's mentioning parameters here, which doesn't come into play here. But if we hit OK, I'm not sending this to a physical printer. I'm sending it to a PDF file. So if I just go ahead with that, and I'm going to choose email just because it's quick to show. Yeah, save it in the default location, replace whatever's there. And now it attached it to an email. Let's just take a look and see how that appears. You've got a nice header here. You could given that a different name. I could have given the project a different name. It's got a time or a date stamp. But then on the second page here, it actually prints out what was showing on the graph. If I would change the way the graph viewed, like say I changed the scaling or something, whatever's showing on the screen is what it would print here. It'll let you know how do you have your buffer size set, what polling rate, trigger position, and so on, and then what channels you're looking at. So that's that, and that covers it. So you've at least been exposed to every function within the MCT10 scoping. You might not consider yourself an expert on it yet, but just given what you've watched, you know more about MCT10 scoping than many folks out there. I hope you'll find it useful. It's a very useful tool for commissioning, troubleshooting, data acquisition. For me as a trainer, it's excellent for doing demonstrations. I hope you found it useful. Thanks for listening.
Thank you for viewing. We hope this information has been helpful. Danfoss drives can provide additional technical support, parts information, or repair services options by contacting us through one of the following methods. For immediate access to customer service or a technical support expert in North America, call 1-888-DANFOSS or 1-888-326-3677, or contact us through email. For technical support, the email address is drives.ts.na@danfoss.com. For customer service, the email address is drives.cs.na@danfoss.com. For after-sales service, the email address is drives.ts.service.na@danfoss.com. Additional information is also available on our website at www.danfossdrives.com. For contact information in areas outside of North America, please visit our global website at www.danfoss.com. Thanks again.